So what we're going to do today is we're going to do some application problems involving vectors, and the application problems we're going to do today involve vector projections and work. So the first concentration we're going to do is the projection of u onto v. So suppose we're given two vectors u and v, and they are non-zero vectors, and vector u and vector v, notice, are sharing the same common initial point. Then when we talk about a vector projection, what we're doing is we're going to take the components of vector u such that w sub 1 is parallel to v. So here is vector v. W sub 1, again, a parallel vector, has a 0-degree angle formed with vector v. That is w sub 1. So we're going to try and find w sub 1, which is parallel to v, and we're going to find vector w sub 2, which is also perpendicular to v. So we're going to be solving for w sub 1 and w sub 2. So when we take these components such that w1 is parallel to v, then w1 is called the vector projection of u onto v. So again, we're given u and v, we're trying to find the vector that's parallel to v and perpendicular to v. So these are the formulas we're going to be concentrating on. So to find vector w sub 1, and again, it's the projection of vector u onto vector v, we're going to have to calculate this particular scalar number. And then we're going to multiply that by the components of v that we're given. So we're going to find the dot product of vectors u and v, and then we're going to divide it by the magnitude of vector v, and then we're going to square the magnitude. Once we find w sub 1, now remember w sub 1 is the vector that's parallel to v. Once we find w sub 1, we're then going to calculate w sub 2 by taking u and subtracting from that w sub 1, which is what the first vector that we found. And again, w sub 2 is the one that's perpendicular to vector v. Again, you don't need to worry about knowing the proof in terms of where those formulas come from. So here's an example. Find the projection of u onto v, then write u as the sum of two orthogonal vectors, one of which the projection of u onto v. So here are my two given vectors. So again, I'm just going to kind of sketch the diagram so I can illustrate exactly what we're doing. So I'm going to sketch vector u, which has horizontal component of 3, vertical component of 2. So there's vector u. Vector v is 5, negative 5. There's vector v. So again, what we're trying to calculate is calculate the vector that's parallel to v and perpendicular to v. So again, I'm going to drop my perpendicular to v. There's my w sub 2. Here's my w sub 1. So there are the two vectors I'm trying to solve for. So first I need to find w sub 1. So to find the vector that's parallel to v, I have to find the dot product of u and v, and then I'm going to divide it by the magnitude of vector v, and I'm going to square it. And then I'm going to multiply that by vector v. So the dot product of u and v is going to be 3 times 5 plus 2 times negative 5. So that's 15 minus 10, which is 5. So there's my dot product. The magnitude of vector v when I square it, so the magnitude of vector v squared will be the square root of 5 squared plus negative 5 squared. And again, I'm going to square it. So the magnitude of vector v squared is going to be the square root of 25 plus 25, which is 50. Then I'm going to square the square root, so it's going to give me 50. So then w sub 1 is going to be equal to the dot product of 5 divided by the magnitude of v squared, which is 50, times the components of vector v, which are 5 and negative 5. So then w sub 1 is going to be equal to 1/10 times 5 and negative 5. So when I multiply 1/10 by the components, that's going to give me 1/2 and negative 1/2. So there's w sub 1. So w sub 2 can be found by taking vector u and subtracting from that vector w sub 1. So w sub 2, again, the components of vector u are 3, 2, minus 1/2 and negative 1/2, w sub 1's components. So W2 then is going to be equal to 3 minus 1/2, which is 2.5. And then 2 minus negative 1/2 is also going to be 2.5. So again, there's the projection of U onto V.